question 2 of the set of exam questions that I posted. This one involves a couple of things that I think might be important to clarify, or that some people I know were slightly confused on. First of all, finding the speed of p at time t equals 2, we're told this thing has constant acceleration. Now, this is slightly unusual for vectors questions because normally we're actually dealing with constant velocity, which has no acceleration. In this case, we do have an acceleration, and we're asked to find the velocity after 2 seconds, or actually, we're asked to find the speed after time equals 2 seconds. But of course, that requires us to find the velocity first. So, because we do have constant velocity, we can, of course, use one of our Suvat equations, and that one would be the simplest, which is v equals u plus at. We're working in vectors here. U is the starting velocity, which is 14I minus 5j, plus my acceleration, which is minus 4I plus j, and that's times by t. This should look quite familiar to you, or similar to the relative position vector sort of formula, right? We have initial something, in this case velocity, it was position, then we're adding on time multiplied by some constant, which in this case is the acceleration, which before was the velocity, right? So this is like kind of a different level of relative position vector, this being the velocity at any time t. So we want t to be equal to 2, so we just say that v equals 14I minus 5j plus 2 lots of this, so it's minus 8I plus 2j, and that gives us my velocity is equal to 6I minus 3j. Okay, now we want the speed. Now again, we've been working in vectors so far, so speed being a magnitude requires us to go from vector to the magnitude of that vector, which just requires us to do Pythagoras. So we'll do the square root of 6 squared plus minus 3 squared, which is equal to root 45, right, which is 3 root 5. So that's my speed. Let's just check that's right. Yeah, okay. That's my speed, it's equals 2, and now it asks me to find the angle between the direction of I and the direction of motion of P. So a couple of things to clarify, which people definitely weren't 100% certain on when going through this question. First of all, how do we find the direction of motion of P? Well, we know what the motion of P is. We know that it's 6I minus 3j. Let's write that here. Whenever you are faced with a question like this, the strategy is to sketch that vector. Okay, so if my vector is 6I minus 3j, I'm going to sketch 6I minus 3j. We're going to go 6 across, we have these convenient squares, and then 3 down. The direction is important here. So that is my vector. That's where P is going at that second, right? At time t equals 2, that's the direction P is going. Then, what is the direction of I? Now, the direction of I is not related to this vector. It's not relevant to the direction of motion of P at all. The direction of I is very simply the vector I. Not 6I, not however many I, not negative I or anything, just the vector I. And how do I draw this on? Well, I go back to the start. So both of these vectors, if I'm trying to relate between the two of them, must start from the same point, and then I draw out I here. So this is I. That's the vector I, right? It doesn't matter what vector I'm traveling along in terms of P, the vector I is that one there that I just drew. If it asked for the vector j, which it doesn't, but if it did, then that would be the vector j there. So the angle between the vector I and the direction of motion of P is simply that angle in between the two there. It's very important that we measure from the same point. If I drew I from here, which is wrong, then I would have a very different angle, right? So whenever you are measuring between two vectors, they come from the same point. That's very important. Well, how do I find that angle? it's supposed to be this angle, and I've drawn I on here, but to actually work out that angle, the only way I can do it is by using this bigger triangle that I have here. So I do need to use 6i and 3j as part of my calculation. And this is obviously a right angle triangle, so in order to find that angle, all I have to do is tan inverse of 3/6. Now I'm talking about the physical triangle here, and I'm just trying to find the angle, so I don't need to put in -3 as my length here. I'm not talking about a theoretical triangle with a length of -3. I'm talking about an actual triangle which just happens to be formed of a vector that's going downwards. So all I do is tan inverse of a half, and that gives me 26.6 degrees. I'm not asked for a bearing, so I don't need to do 3 digits. 26.6 is fine. I'm not measuring from north. It's literally just that angle there. You would also be allowed, and if you look at the mark scheme here, you would also be allowed this angle around the outside as well. So you could do 360 minus 26.6. I don't know why you would, but you would be allowed that, because either of those is the angle between the direction of I and the motion of P. Okay, now let's look at part 3, and this is one that I wanted to touch on and probably will touch on in class, but it's one where you're asked to find a time when P is moving in a certain direction. In other words, parallel to that direction. It doesn't mean its velocity is exactly 2i minus 3j. It means in the direction of, which means parallel to. So what do we do there? Well, we know that the velocity is equal to 14i minus 5j, that's the initial velocity, plus minus 4i plus jt. Right? That's what we came up with here in order to work out the velocity at t equals 2 seconds. And we can again rearrange this so that we have all our i's in the same place. This should generally be your instinct when you're working with i's and j's anyway. So we have t minus 5 there. My j component, right? This is nothing new to you. Now, we want to be in the direction 2i minus 3j. So we want to be like this. How do we get that? Well, this is like what we did in exercise 3b, if you can remember, when we were asked to find t or some constant when our vector is parallel to this vector. And the way that we did that was relating the I and j components together in a proportion. Now, what I didn't tell you at the time was actually there is a much easier way to do that. I didn't tell you because I forgot. But the easiest way to do that is actually to use the proportion, use that ratio as a fraction. So represent that ratio proportionally as a fraction. What we can say is that the I components over the j components as a fraction will be exactly the same as their ratio here. So 2i and then minus 3j, that will be the same ratio. So you can literally write this as an equation now. We can write 14 minus 4t over t minus 5. I suppose I should write capital T because we're looking for capital T in the question. So 14 minus 4t over t minus 5 is the same proportion as t over minus 3. That's an equation. We can solve that equation now. So if I multiply up, I will get 12t minus 42 equals 2t minus 10. And then I can solve this. I get 10t equals 32 and t equals 3.2. So I'm doing exactly what we did in exercise 3b, what we had a little bit of practice with, but this is just an easier way to do it. Now, sometimes, if you remember, you will just have parallel to the I vector, in which case all that means is that your j vector is 0, or parallel to the j vector, in which case your I vector is 0. Sometimes you get parallel to I plus j, in which case they're just the same. But when we have any question where the direction is something slightly more complicated like this, it's usually easiest to use this sort of ratio fractional method here. So maybe if that's if that makes total sense to you, then you should be fine. But it still might be worth having a look back at exercise 3B and just using this to do a few of those questions.